Hey everybody, this is Mr. Beckstrom, and today I'm taking a look at an example from section page 285, section 4.5 optimization problems. This is number 17, and it says a rectangle constructed with its base on the diameter of a semicircle with a radius 5, and its two other vertices are on the semicircle. What are the dimensions of the rectangle with the maximum area? So I kind of already drew it out here. It has a radius of 5. And I also connected the center of the semicircle with the outside here because we know that's 5 as well because that's also the radius, and we're going to use that as part of our constraint equation. All right, so I'm going to change one little thing here. I think it might make it a little bit easier. Instead of calling this whole thing L, I'm just going to call this section here L, so that way, and this section here W. So the actual area of the rectangle is going to be the width times 2L, because we have an L on both sides there. All right, so let's set that up first. So we have area is equal to, it's really the length times the width. The length is 2L, because we have an L and an L, and then times the width. So this is our objective function. And the first thing that we really want to do is we want to try to get this into one variable if we can, and we do have a constraint equation that will let us do it. This line segment from the center of the semicircle to the edge of the circle here is also the hypotenuse of this right triangle, so we can set up that equation. So the hypotenuse squared is equal to one leg squared plus the other leg squared. So I can set up an equation like this. And then in this case right here, I'm going to go ahead and solve for length and then substitute it back in there. So L squared is going to end up equaling 25 minus W squared. And that means L is going to be equal to the square root of 25 minus W squared. And I don't know why it does this sometimes. 25 minus W squared. Let me see if I can take that. Let's do it. All right. So doing this, then I can easily go up here and do a substitution. So the area is going to be equal to 2L, or excuse me, 2W times, for this L, we're going to put in the square root of 25 minus W squared. All right, so here is our objective equation in one variable, which is the width here. And so we're going to solve this first here. So the way that we do that is we're going to take the first derivative, and then we're going to set that equal to 0. And what that's going to do is going to show us any local mins or maxes in this function here. We also know that we're looking for an area somewhere between 0 and the longest it could be is 10. So, so for the 0 to 10, and if we're actually just talking about L, it's really between 0 and 5 because we divided L in half like that. So between 0 and 5. All right, so let's go ahead and get to this. So A prime, it's going to be using a couple of our derivative rules here. So I'm going to use the product rule. So it's the first, which is 2W, times the derivative of the second. I'm going to use the chain rule for that. So bring the 1/2 out front, and then I'm going to have 25 minus W squared raised to the negative 1/2, and then times the derivative of the inside function, which is negative 2W. And then that's going to be plus the second term, which is simply 25 minus W squared. Oh, why do you do that? W squared. So the 1/2 times the derivative of 2W, which is just 2. Okay, so I'm going to clean this up a bit, and I should get Hold on just a moment here. Let me give myself a little bit more room. All right. I should get that the derivative is equal to negative 2w all over, that's going to be 2 times negative 2 is negative 4. Negative 4 divided by 2 is negative 2. And then w times w is w squared all over. And I can move this down to the bottom to make this the square root of 25 minus w squared. Minus w squared. And this is going to be plus, and this will just be 2 times the square root of 25 minus w squared. And we're going to set that equal to 0. So I'm going to go ahead and combine these two functions here. So 0 is equal to, I can multiply the top and the bottom of this by the square root of 25 minus w squared. So that's going to give me negative 2w squared. And then multiplying that by the top, you're going to get 2 times this here. So that's going to be plus 50 minus 2w squared. And this is all going to be over the square root of 25 minus w squared. So as long as our answer isn't 5 or negative 5, we can just look at the top there, because as long as the top is 0 and the bottom is non-zero, we're going to get a 0 there. So once again, we just can't have a 5 or negative 5 in our solutions. So let us go ahead and do this. So this is going to be negative 4w squared plus 50 is equal to 0. That means negative 4w squared is equal to negative 50. And w is going to be equal to, that's the square root of 50 over 4, which is the square root of 25 over 2, which is equal to the square root of 25 over the square root of 2, which is equal to 5 over the square root of 2. All right, so that is our width. So going back here, that's going to be our W. And in order to find the L, we can just plug that W into this equation here. And we should get the same value for the L, and then you just have to double it. So the L is going to end up being 10 divided by root 2. All right, guys, if you have any questions, please let me know, and I hope you all have a great rest of your week. Thanks.